So here's another problem. So we have a vertical plate is partially submerged that's shown in water. So find the hydrostatic force due to pressure. So here we are given the weight density delta is equal to 62.5 pounds per feet cubed. So the first thing to note is that this entire piece of plate is not completely in the water. So let's just say that everything in the blue is just water. Um, so, because not everything is in the water, we're gonna kind of ignore for a second this top part. So the top part is not really relevant just yet. Um, but also note that the pressure that you feel maybe here is going to be very different than the pressure that you feel down here. Because the further down that you go, the more pressure you're gonna feel. So the pressure in this case is not constant. So that's something to really note. So the first thing that you kind of know or try to figure out is figure out what this force should be. So we know that force is equal to the area times the pressure, or the air or pressure times area. Um, so first, let's figure out what the pressure is. Okay, so find pressure. So we know that the formula for pressure should equal to rho g times d. Now, this formula is not really going to work because rho is the mass density given to us in kilograms, and we do not want that. Instead, notice that everything is in feet. There's no meters here. There's also no kilograms, so we actually have pounds. So in this case, we had to use this weight density. Okay, so in order for us to have it in US customary units instead of SI units, would be delta times D. Okay, so we know what delta is. Delta is going to be 62.5, and then D is going to be the depth. Now, in this case, the depth is going to be very tricky because you're going to feel pressure at different depths. So what I'm going to do, I'm going to cut out a little strip here. So let's say this is a thin strip, and I'm going to try to find the pressure of this particular strip. So from the surface down to the strip, I'm going to say that's xi. So that's what I'm going to plug in for D. So that's the depth, xi. So that is my pressure. So for this particular strip. Okay, so now that I found this pressure, the next thing that I want to figure out is find the area. So find area. And how am I going to find the area? Well, we have this little strip. Let me go ahead and draw it one more time here. So we have this trapezoid. Okay, so we have this little strip that I just put here. And I know that I need to figure out the area of this particular strip. Now this strip, the shape that it has is the shape of a rectangle. So basically, I just need to figure out the area of a rectangle, which in this case will be length times width. Okay, now if I were to say that this guy right here is the distance from one strip to another strip, so imagine that I have a lot of different strips, that's just going to be delta x. Okay, so let's just label that the width. So all I got to figure out is how long this strip is. Okay, so let's just say L times delta x. Now, how am I going to find L? Well, let's look at our shape. So our shape, we have this trapezoid that can be basically broken up into three different familiar shapes. So here we have another three different shapes, two triangles and one rectangle. We are given in the problem that the top part is 4 feet. Because this is 4 feet, that means that the bottom part right here, just this guy, is going to be 4 feet because that's a rectangle. Okay? We also know that the bottom part is going to be 8 feet. So all of this guy is 8 feet. So if I know that this guy is 4 feet, the other guy should be 2 feet each. Because if I were to add all of them together, I would equal 8 feet. Now, notice that you have a couple of things. Here you have 1 foot. Here you have 2 feet. So that means that the total distance or the total height of this thing is going to be 3 feet. So from here to here is going to be 3 feet of this trapezoid. Okay, so basically what I want to figure out is I want to figure out what this guy is. I want to figure out all of this. Let me just write it in green. I want to figure out what all of this guy is. This length. Well, I already know what this one is. This thing is 4 feet. I just need to figure out what these small portions are. Okay, let's just label those A. It's A and A. So basically the entire length, this length is going to be basically A plus 4 plus A, whatever that may be. So what we've got to figure out is find this little A. So find this A. That's what we need to find. Now, how are we going to find it? Well, because this A lives in these triangles, let me go ahead and take out one of these triangles out. Okay, so I'm going to take out this triangle. Okay, we said that the bottom part is going to be 2 feet. Okay, the whole thing is 3 feet. And then you have something smaller here, which is going to be A. Okay, so now what we're going to do is we're going to try to figure out what this is going to be. Now, let's try to figure out what these sides should be. This one and this side. So notice that the whole thing is 3 feet. Now let's go back to my little figure over here. We know that from the surface to this little strip is xi. So how much is it from the strip all the way to the top of the trapezoid? Well, that's just xi, because this guy is just xi. This part right here is xi, plus this amount. What is this amount? Well, that amount is just 1. So this whole thing is going to be this xi plus 1. So this part is going to be xi plus 1. So that means the bottom part should be 3 minus xi plus 1 in parentheses. Okay? So this part right here, I'm going to write it over here because I'm running out of space. It's going to be 3 minus xi plus 1. That's basically what that is. Okay, so let's try to set up the similar triangles. Okay, because you can see that I have one triangle right here. That's the first triangle, which is going to be what? So what is the ratio between these? A over xi plus 1. Okay, all right, is equal to the ratio of the bigger triangle, which is this guy right here. This big triangle, which is going to be 2 over the big side, which in this case is going to be 3. 2 over 3. Notice that I didn't really need this guy right here, okay? All right, so now what is this going to be? Let me multiply this bottom part to the other side. Okay, so I'm going to have A is equal to 2/3 times xi plus 1. Okay, which is going to give me A is equal to 2/3 xi plus 2/3. Okay, so now I finally figured out what A was. Okay, which is basically this guy. So now let's go back to my A. So we knew that my A, or my area, is equal to the length times the width, which is equal to the length times delta x. Now we figured out what my length was. My length was initially just as A plus 4 plus A. And then we had this delta x on the outside, because we had this delta x. We just figured out what A was. It is just equal to 2/3 xi plus 2/3. That's this A. Then we have this plus 4. And then we have this another 2/3 xi plus 2/3 times delta x. Okay. So this is going to give me what? I'm going to go ahead and clean this up. I'm going to have 4/3 xi plus 16 over 3 times delta x. Okay. All right, so now that I have that, all we got to do is, now that I have my area, I finally got my area. Here's my area of that little strip. We also have our pressure. Now we are ready to plug it into our force. So force is equal to the area times the pressure of this particular strip. So this is just one little strip. So the area in this case is going to be this guy, 4/3 xi plus 16 over 3 delta x, and then times my pressure. My pressure in this case is going to be, what was it? 62.5 times xi. Okay. All right, now notice that, let me clean this up a little bit. Let me put the 62.5 xi on the front, then 4/3 xi plus 16 over 3, and then delta x. Okay, so this is the ith strip, just one particular strip, but we don't want just this one particular strip. We want all of the strips in this particular trapezoid. So we want all of these guys. We want all of them. Okay, we want an infinite amount. So what we're going to do is we're going to say that the total force is going to be the integral of this guy, 62.5 x, and then times 4/3 x plus 16 over 3. Delta x is going to turn into dx, okay? And then what am I integrating from? So it's not from 0 to 3. It's basically everything that's submerged. So if I say this is 0, it's going to be from 0, from the surface, all the way to the bottom part, which in this case is 2. So this is going to be from 0 to 2. Okay? Alrighty. So now all I got to do is let me go ahead and distribute this out. Okay? So I'm going to have the integral from 0 to 2. Then I'm going to multiply 62.5 multiplied by 4 over 3. Okay, and that's just going to give me 250 over 3 x squared plus, and then I'm going to take 16 over 3 and I'm going to multiply it by 62.5. And in this one I got 1000 over 3x dx. Okay. All right, and now all I'm going to do is I'm going to go ahead and multiply or take the antiderivative. So this is just going to be equal to 250 over 3 times x cubed over 3 plus 1000 over 3 x squared over 2 from 0 to 2. So then I'm just going to plug in the 2. So times 2 cubed over 3 plus 1000 over 3 times 2 squared over 2, and then minus 0 because everything's going to go to 0. And what I'm going to get is 8,000 over 9, which is approximately 889. And in this case, it'll be pounds. Okay, so yes, this was a really lengthy problem. It's a little bit more of the harder problem, but it's very self-explanatory. It involves a lot of different things. It involves similar triangles. It involves a little bit of geometry, and obviously it involves calculus. So yeah, that's basically it for this problem.